We're now going to do pretty much the exact same thing for the back end. So we're going to go through the various APIs and concepts that you're going to be using regularly, and then some other ones that might not be quite so common but are useful to know about. The main thing is, as you will have probably already seen, Dallinger expects you to have a class that is a subclass of experiment. And this is kind of what holds all of the back-end logic for your experiment. That's registered as what's called an entry point with Python. That's not something you really need to worry about. It will be done for you when you generate the application. And the backend is responsible for things like deciding how many participants you need, how they communicate with each other, how much they're paid, or even if they're paid. And there's a lot of different models in the database with subtly different names. We've covered some of this already with participants versus agents, but you may recall I think I called agents nodes at one point, because an agent is a type of node, but we'll go through them. So to start with, an experiment, the experiment class, that is the experiment being run, the thing that is deployed up onto Heroku and people come to visit. If it could be testing multiple things or running a test multiple times, but the whole thing all together is an experiment as far as Dallinger is concerned. Network is how people interact, how data is transmitted along a transmission chain, or how people can see what other people are doing. So it could be a chat room where everyone can see each other, or it could be iterated drawing where we have 6, 10, 15 people having data passed from one to the other. A participant, we talked about briefly with JavaScript, is an actual person who has come to interact with the experiment, and then they interact with networks as agents. Info, again, we saw this in JavaScript. That's a container for the data that either gets received or sent. Now, node is anything that participates in a network. It takes a base spot in a network. And so far, we've only really been talking about agents, but there's also sources. Sources are things that participate in a network by only sending data to that network. They don't receive any data. So the first spot in a network is usually taken up by a source, because you want your JavaScript front end, your agents, to be given data and then send data out in the same format. If you don't have a source to begin with, then the first person doesn't receive anything, but they have to generate it. So, for example, with iterated drawing, if you didn't have a source, what you would get is someone not being shown a picture and then being asked to recreate the picture. So they could draw something, and then the next person would receive that. So the function of the source is to prime the experiment, prime the users with a known piece of initial data. Yes?
If we imagine this graph as a tree, a source could be a potential root, but
yes,
an agent can also be a potential root.
Yes, exactly.
There's no requirement for a source, but there must be a source.
There is no requirement to have a source. There's also no requirement that there's only one source, although it's only really useful to have only one unless you've got a network that's got an unusual structure, like with multiple roots or multiple start points. If you have no source, you only have agents, then you need to make sure that your JavaScript has been written in such a way that it doesn't fail if there is no incoming data. Because if there's no source, there will be no incoming data for the first user. Yes?
Maybe still a follow-up question, but if I want to make some discriminative survey, like I have a human and artificial generated for some data, and the next node has to discriminate whether the first node was a human or a machine, would that machine be a source node, or is an implementation of an agent?
It would be a source node, is how I would do it. You could probably do it as an agent, but I would do it as a source. Do you agree with that, Jordan? You looked a bit unsure.
No, just interesting you said that. Can you actually say it one more time?
Yes.
What's the decision this week?
So some Turing test. There's some generator, and this could be participant, a human participant that is getting paid, or something, some deep learning, whatever that I made up. And the second participant has to discriminate, based on the output of the first node, has to discriminate whether this was natural or artificial. I was wondering how would I implement this first node being that artificial.
I'm planning to describe that as a source.
Yeah, so the way I would do that is I would have effectively a network that is two nodes that are each connected to one node. And I would say one of these nodes is a source, or maybe both are sources if they're both machines and you want to play games, or both are agents if you want to play games. And I would write the JavaScript so as to say, if you don't get any input coming in, then ask the user to create input. If you get input coming in, there will be more than one, and you'll ask the user to pick which one you want. So there are ways of doing that we can talk about later when we get onto agents, but that is how I would do that. As agents are things submitted by people, and sources are things created by machine. They fulfill the same interface. You could write them both as agents, but there's no reason to do that, and I think it's clearer to do it as a source. Any other questions about? Oh, sorry, and transformations. Forgot transformations. When a user submits info from what they've done, so say they're doing the Bartlett recall the story demo, it's possible that they will have done something there that needs tidying up. So maybe they wouldn't have done any punctuation, and you want to say, before I pass this on to the next person, I want to run it through an automated system to fix capitalization and punctuations. Or say it's the iterated drawing, you might want to do something that gets rid of any extraneous dots around the edge, something to tidy up the data that the user has done, just so it's not confusing to the next user. A transformation is something that is applied in Python that converts automatically one info to another, and it says, it makes it explicit that this info is an updated version of this one. So you can then go back through your data and say, okay, well, where did this info come from? It happened because the Python code decided that it needed to make an adjustment before sending it on to the next person. So it doesn't do anything magic about changing the infos. It's just kind of a way of marking it as saying, we've done something to change this data. This is the before, this is the after. We want to keep both of them in the database.
So with it, I think one of the non-intuitive things in Dallinger is how we use transformation. Mm-hmm. A lot of people just avoid them altogether. But what do you think? Just give another use case. Imagine that I'm having something that requires processing, like an audio or something like that.
Yeah.
And then I want to extract something of the audio. Would be a good use cases to have one info which be the link to the core audio, and then another info which would be the information that was extracted from the audio. Because another alternative would be to update the info, the original info. But the idea is not to do that.
You should definitely not update an info, because if you do that, you'll be discarding what a user has submitted. So if you later find out that you've done something wrong with your transformation, you can't then go back and see what mistakes were made. So I've said a few times that you should write your experiment so that you receive data in a known format and you send the info back in that same format. But what a transformation allows you to do is to break that promise. So you can say there's a bit of text that you're shown and you ask someone to read something out. So say exactly the same as Bartlett, but instead of type it in, you have to recount the story into a microphone. That means that your incoming info will be text, but your outgoing info will be audio. And you can't then show the next person text because all you've got is audio. What you would do there is you would use a transformation to say, in your Python, I'm going to send this off to a transcription service, either an automated one or a human one or whatever, get text back, and then create a new info with that text and use a transformation to say these two are the same, this is a transformed version of this one, so that you have a full log in your database of this is where the information has come from, this is how I found it. Yeah? It's not a piece of functionality that is widely used, as I understand it. The MCMCP demo uses it, but I don't think any of the others do. But it allows you to do some really complex and really powerful things if you need them.
Another thing about transformation that I once heard from Thomas Morgan is that if you have some kind of thing like a chatbot where you want to mark that two infos are somehow connected, would be that another use cases, or in this case, like imagine that like there's two users and they're sending info from one another. Is that another use case?
Yeah, so you can use transforms for marking arbitrary relationships between infos.
Yes.
So, yeah.
So if you have because you can connect nodes to another nodes via network through a vector. It's not reported here, but they are connected in a network by connections. This connection calls a vector, but you cannot connect infos by vectors, right? So if you would have something like a chatbot, where you somehow want to mark the relation between the infos, that you can do it with a transformation.
Yeah.
Am I saying something correct?
I think so. So on the front end, you want to make sure that everything that the user is doing that you want to store in the database for later analysis is created as an info. If you are also doing things in the back end that aren't so much, that are creating infos, you use transformations to be explicit about this is why it happened, this is a version of this info, or this has been created of a synthesis of these infos because of some rule. And that allows you to record these decisions explicitly rather than having to try and infer them from the existence of these new infos later.
Yeah.
So if you're saying using transformations allows you to break whatever interface that your graph may have, why would you use a specific class at all? And why don't implementing some arbitrary class with some arbitrary functionality and then calling it in between?
Well, that is actually what you do. What you do is you say that your arbitrary class that you develop will be a subclass of transformation. Yeah.
But conceptually, in terms of a graph, this is something that links info, where if you want to connect nodes, they're connected through a different mechanism, which is called vector. We usually don't really need to think much about vectors because you look at membership in a network or something like that. But that would be the thing that connects nodes.
Yeah.
And that's connecting.
So for this, I'm not going to do the functions you always need and the ones you need less often. I'm going to start with the different phases of the experiment and say which ones you will generally have to implement to do each phase. And the first one in the setup phase is configure. This one, unless you are using the latest version of Dallinger, you will not have seen because it was added in the last release. Configure is a way of just storing information on the class that only happens once, really, when the experiment is set up. Configure is called every time that the experiment class is initialized, as long as it's connected to a database. So throughout a Dallinger experiment, it will always be connected to a database. The only caveat is if you just open a Python interpreter or a Jupyter notebook or something, import the experiment and then instantiate it, this won't be run. So here you do all the things that you need to do for a running experiment effectively. So here what it's saying is look at the config file, see all non-participants and store it on an attribute so I don't have to go look at the config file every time. It's just basic setup. One thing you shouldn't do is you shouldn't make any changes to the database in this section because this is run many, many, many times. It's run once for every HTTP request because every HTTP request needs to have access to the experiment object. So if you make any persistent database changes here, they will happen every single time someone accesses the site. So this is just pure Python setup to make it easier to write your methods on the experiment. Setup is a bit more complex. This one does the persistent changes the first time it's called. So it's called many, many times, but it checks every time, are my networks set up? And it uses the fact that networks are set up or not as a proxy for knowing, has the setup been run? Is this the first time that it's happening? If it is the first time, what it does is it creates all the networks that are defined. If you don't implement this, it will use the default behavior, which is to create every network for what are called the practice runs and the main experiment runs. So you can configure your experiment to say, I want people to run through the experiment 1, 2, 3, 0 times as a practice before I give them real data. So you can give them an easier version to make sure they're familiar with it before they start being tested. You don't really need to worry about that. That's the default behavior. If you want to do something special, such as here, the Rogers experiment, I don't remember what the Rogers experiment is. Do you want to, is it useful to know what that is?
That's basically the one that I've been talking about, where you recruit a generation of people, send them away, recruit a new generation of people, each of whom learns something from a member of the previous generation. And so the point being here that there are multiple networks being run in parallel, because we're running each participant participates in multiple instantiations of that simulation.
So what this is doing is it's saying, for the setup, if there aren't networks, call the default implementation, and then a random sample of these are going to be handled separately. So this is a way of saying some of the networks should follow a different rule to other ones. That's how you would do this. Yes?
Could you clarify what is the exact lifetime of the experiment instance? Because I thought it would live throughout the whole experiment for a given user, but now you say once per HTTP request is instantiated.
It can be once per HTTP request. It can also survive between HTTP requests for different users, but that is not guaranteed. The experiment instance is, generally you should assume it's recreated for every HTTP request, so it's stateless effectively. Anything it needs to store should be stored in the database.
But then how would you have self networks defined if it is instantiated and you
Sorry, how would I have what different?
Self is a property.
Yeah.
Instance,
Okay.
right?
So the experiment class has a bunch of attributes on it, such as networks, participants, and things, and these are wrappers around database calls. So when you do self-networks, what Python does in the background is it says, has he already checked this in this request? If so, I have a copy of the networks I can just do. If not, it transparently goes to the database, does a database query, pulls that data out, instantiates the network object, and then gives them
So
to
the
you.
designer of the experiment is responsible to handle consistency entirely through the database interactions.
It will generally be completely transparent because it's done on the base class of experiment. So as long as you do class my experiment brackets base experiment, you will get all the stuff about networks, you will get all the stuff about participants and nodes and transmissions. The only thing you need to do is when you create things, they need to be attached to this graph so that it knows to store it back into the database at the end of the request.
So I just have to make sure that I use the proper MPIEA call to handle the information that I want to be consistent.
Yeah, and it should be pretty transparent. If you look at any of the demos, you will see them creating nodes and infos and things, and it's a bit strange the first time you see ORMs because they seem really magic, and that's because they are really magic. It saves a lot of time, and the problems you get are quite infrequent. If you do manage to get a problem, then it will maybe be confusing, but the fix will always be pretty simple. It will just be a typo or a missed line or something. They're relatively intuitive once you stop worrying about what it's doing behind the scenes. Create network is, so I should just emphasize, these are functions that you can choose to define on your experiment class if you want to. You do not have to define either of these if you don't need them. Same with create network, but almost every experiment will define create network, because create network is what decides what the network is going to be. So you might have repeats and things, so this will be called by some part of the internals, but the default implementation of create network is to return an empty network with nobody connected to each other. This is what lets you say, I want to do a transmission chain, or I want to do a discrete generational network, or I want to do one where everyone is connected to everyone. We'll go into those things in more detail later, but this is a pretty important thing to implement. Here, we created networks, but some of them were different. But here we have a thing to create networks. So you might wonder, why didn't we create two different types of network here and pick randomly? There's no particular reason not to, except that you don't have any guarantees about how many times create network is called. So it's generally that the pattern we've been going with is create network should be your default one, and if you want to change any of them, potentially randomly or potentially according to a pattern, you would do it in setup, because setup has the full list of all of them, so it can make intelligent decisions. Although, of course, if it's random, it's going to be the same either way.
But there is one question that we had preparing for the workshop is that what's wrong about create network on the fly? So I imagine that a participant come. Usually the way a lot of the Dallinger example are set is that like all the networks are created in advance for the participants. So like we have transmission chain experiments with X things. The participant comes, all the networks are prepared, is assigned to a network. What is the downside of like having the participant come and then create the network for them?
So we are going to go into this in more detail in the talk specifically about networks. What I would say is there is no particular downside, and I would do that if you had a network where participants can influence how they are connected. So maybe you had something where you are given a list of other people and you have to pick who you want to, pick 3 people and you'll be connected to them. You can just write it so that it follows a rule, but if you were following a rule, I would generally do it as a network because it's more self-contained and it's easier to
So imagine
use.
a use case, for example, you're running an experiment like MCMCP, and you run in parallel like 20 networks, okay? So the participant comes one by one, they play 20 networks, and then another participant comes, he plays again 20 networks. So one way to create it is to create in the beginning like 600 networks, and when the participant comes, assign to him 20.
Yeah.
But alternatively, you can just wait for the participant to come and create for him, just for him, 20 networks. Somehow it's not the way that most of the examples seems to work, and we were wondering, is there a reason for that?
Okay,
Is
so
the question clear?
So you're talking about when a user comes in, create the networks just for them because...
Multiple networks,
Yes.
Especially if you run multiple, it's just the use case of, in case the user is going to participate in a number of those, say that they're all private just for you.
Yeah. I think the only advantage of preparing them in advance is that's what the code is set to expect, so it will be less work for you. But it means you will potentially have some extra networks that don't get used depending on your experiment config. I don't think there is a persuasive argument either way.
It's no, like, because we were wondering whether like there's some performance issue or something like that, because actually it's pretty easy for a participant just to create the networks on the go, because then we don't have to like bookkeeping for that participant. Like he finishes available networks for him, and then that's it. And then it's more easier in other ways.
But what I would probably do for that, if I wanted, so has this person got input and output?
Yeah, as I mentioned that each one of us doing some chain experiments is going to participate in 10 different experiments, and you want a random order. So you got those 10 chains, you're going to go iterately around them, eventually fill all of the spots, and let's go away, and another participant came. So there's no sharing across participants. So it's
Okay,
so you're transforming an across participant design to within participant design.
So it's one participant who will fill all the spots in a network.
Yes.
Okay. In that case, yeah, I probably would do it as you were suggesting, because otherwise you'll have to customize your network so that they know not to offer everyone a spot in each one.
Exactly.
Yeah. The thing is, I believe that some of the code, there's a function I think we talk about later on, either in this talk or later on, about deciding if a user can join a network or not. So you will have to customize that either way to say, okay, yeah, this user is allowed to be in this network even though they've already been in it. But
I think you're there's no right getting away. I mean, both cases.
yeah, so I think that's far enough away from what is expected to happen in a transmission chain by Dallinger that you are always going to have to do something that's a little unusual, and I think either approach is fine.
I think I see another slightly related issue with this paradigm, but maybe I'm misunderstanding. So you have this chain, and by the question before about the experiment lifetime, you would infer the current position of the current agent by looking at some table in the database through the API or whatever, and counting how many have been there. So if max size is 10, and we have already 6 entries, I know that I'm the 7th. Would that work that way?
For networks that have a defined ordering of nodes, yes, but most of them do not have a defined ordering of nodes. You would be the 7th person to join it, but you wouldn't be the 7th place in the network, if that makes sense.
Okay, but just regarding the capacity, what happens if the 9th guy just drags for hours the workflow and we invite another 50 people for just the 10th spot? Is there here a way to prevent that with this paradigm?
So you wouldn't invite 50 people because it's not time-based recruitment. What happens is it would recruit another person when another one was needed. So if someone was spending hours and hours and hours and they were the 9th spot, then it wouldn't ask for the 10th person until they either were finished or until their time ran out and they were kicked out. And if they're kicked out, it wouldn't ask for the 10th person, it would discard the 9th person and ask for a replacement 9th person.
This is one way to do it.
Yeah.
The other way to do it is to some kind of implement a close open network structure, which that participant that is stuck, gets stuck, basically get that network particularly stuck, but other networks are still alive.
Mm-hmm.
What happens is there is a certain time limit. You can set it up. Usually in the experiment that Jordan was set, it was set to 6 minutes. So after 6 minutes, this person will be thrown out, and his data, there's going to be something called data tech that's going to clean everything from, it's going to fail all this data, and so that's the guarantee. However, usually I think it's a good practice to change this to a larger number, like an hour. And if you have a lot of networks, that means that a couple will be stuck for maybe an hour. But assuming they run experiments for a couple of hours, there will be enough open networks, so to speak.
But then you said when you do that, you have some contract with Amazon that once you open this amount, you will eventually end up, filling all this amount. So it would be a pity that just for this reason you would have to increase your capacity by 100, your budget by 100.
Let's take it offline.
Yeah,
It's a good question, but
So we're going to go into the networks in more detail later, but this create network is, as I say, the one that defines what your default network will be. The default is empty. This one is using chain. These are the ones that are built in. I'm not going to go into any real detail about what they do because we're going to be talking about that tomorrow. I mainly put this up here to show there are a lot of options built in, and as Nori said, you can always work out your own things later. You can create arbitrary connections. You can define your own ones. As I say, we'll speak about that tomorrow. So those are the things that you really absolutely need to consider before. But to make sure an experiment can start up. But people have to join the network as well, and there's a few functions we might want to define there. Add node to network is a pretty basic one. By default, it will just it will call network.addNode, which is effectively saying it's entirely up to the network how this user gets added. But what you can do is you can override it to do a bit of code as well for when a user joins. And a common one to add is this pattern here, which is find the parent. So that says, assuming there's only one person connected to this node, tell that parent to send its data on and the node to receive it. We've talked about transmissions as a way of moving an info from the output of one user to the input of the next. This is how you do it. You have to call transmit on the one that it's an output of and receive on the one that it's an input of. If I was doing this is just copy and pasted from a demo. I probably wouldn't have that 0. I would do for parent in this transmit and receive, because that makes it a little easier to do multiple parents. And yeah, you will see this particular implementation for most networks, for most experiments. Get network for participant is given a participant, return one network that you want that participant to be joined to as an agent. So this is what we were talking about earlier with if you want a network all for one user, or you want a user to be in a network more than once, this is the function you need to define to decide that. And the reason it takes participant rather than agent, because remember an agent is how someone joins in a network, is because at this stage they are not in the network. This is saying this is a person, you can use the participant object to find all the nodes they have previously, so you can see how they've interacted with networks in the past. Which network should I create a node for them for? So you don't have to manage the node creation, you can override this just to define the logic of which network they see. So in this particular one, it's saying participant.nodes brackets failed equals all is all the nodes for this participant, whether or not they were marked as a failure or not. If that number is less than the number of trials per participant, so of all the nodes that they have done, whether or not they were failed, if that is fewer than the number of times we want this person to participate, give them a random network. So that can be a network they've previously been in or one they haven't been in, there's no check there. Otherwise, return none. And if it's none, that's what triggers this 403 flow, which returns the error for the create agent function in the front end, which then sends them onto the questionnaire. So return none here is the same as saying I want this user to be done and be sent to the questionnaire and be paid. Return a network is I want a new agent and a new trial for this user. Nori, is this something that you did for your experiments?
Yeah, I mean this is something that, from my experience, you basically implement a network for every single experiment. You can use chain for some experiments, but in many cases you would actually implement your own stuff, and you would basically implement get network for participant in something, and then also add network for node for network.
Yeah.
So there's two things that are basically kind of inevitable.
So create network is what decides the structure of the network. Add node to network is what decides what happens when a user joins a network. And get network for participant is what decides how users are assigned to networks. These three really do control everything about setup.
Can you repeat that slowly?
Yeah, sure. Sorry.
Actually, for each one of those, I'll just say what it is in the context of the Bartlett memo.
Yeah, okay. So create network is what creates the default network, which is the shape of how all the nodes, agents, sources interact.
Right, and these are basically all defined as where do we put a new agent when they're added to a network. And so chain, for example, is an algorithm that says where you put a new agent who's added to a network is you attach them to the end of the chain, which is to say you look at whoever joined most recently without them, and you add a link from them to the newcomer. So that's chain in the particular context of the War of the Ghosts demo.
The next one is add node to network, which is given you have a node that wants to be added to a network, make sure that node is added and do anything that needs to be done specific to your experiment as part of adding it, such as transmitting the info from the previous one.
And the reason why that cannot be general because the transmission could be different in different networks.
So it distinguishes network structure from the process that plays out over that network. And so add node to network is both going to, like, the first call here is, actually call the one that we just talked about before and actually add them in terms of the structure of the network, but then do whatever the process is. And a transmission chain, in those words, transmission and chain, it defines both the network structure, chain, and the process that plays out over that, which is this very particular process where the ground truth source transmits information to the first node, first node, the second node, the third node. But you could have a chain where a different process played out over it. For example, one where it's still a linear chain going forward, but on every round, the source transmits a new piece of information. And so rather than just one A to B to C to D, maybe it's A to B to C to D, and then again, and then again, and then again.
Or the case of transformation we just mentioned would be again here. Imagine that each node needs to go through a certain transformation. Then the transformation will be called from here, will happen, and then will be registered.
This is my problem. That's why I want to get to the third point, is that somehow in create network you define this topology, but then in get network for participant you also define the topology. So I don't
well, no. So the last one is given a participant and you know all the networks that are available to you, where do you want that participant to next take up a spot? So if there's only one network, it will just be that network, assuming you want that participant to be in it. If there's more than one network, which network do you want that user to look at next? So this is given a user, do I want them to do anything else in the experiment? And if so, which of the networks available to me do I want them to take up a spot in? And this isn't saying they take up a specific spot. It's saying, I want you to create a node for that participant and then call this, and I'll give you a network and then call this with the node and the network.
So instead of pointing the participant to a specific node, you point it to a network, and then the add node network of that network will select the specific node for that network.
Yeah. So this is the broad structure of how do participants relate to networks, and this is the what happens when a participant joins a network, and this is what is the internal structure of a network.
Yeah.
So that they kind of layer on top of each other.
My mental model of this is like we're in like a lab space where there's a bunch of individual rooms where groups of people are getting together to do some tasks. Like each room is going to have its own transmission chain in it, and then like a new participant comes and they're like, okay, good, I've done all my I've finished everything for today. Can you give me where do I go next? And you're just like, oh, which of these rooms needs a new participant? And then like every so often people are going to come out of there once they've done their task in that room with that network, and they're like, and maybe you set up your experiment to just go pay them and let them go away, or maybe it's like you're going to keep them around and say, okay, now they're going to do their next round, and like, okay, now go to that room which is open. So it's like participant. The concept of a participant exists as the kind of like meta game of the network. It's not like participants and nodes are not commensurate. The participant is a person who, in the context of any particular network, will take on the role of a node. And this is the function that says which room, which of these networks, which are totally different universes, which of these networks should you go join?
So Nori mentioned earlier, so what if I had a case where I had multiple chains, just multiple networks, and instead of having people, a person participate in just any chain, I wanted to get a fully within subject design where a person starts with one chain and then finishes that, and then maybe completes another chain, would this be go through the spot? So instead of having a random choice where here you can go back to a chain that you've participated in or go to a completely other chain, instead I customized code to actually have a person just receive the response that they gave before until they're at the end of the chain and then be randomized to another chain.
Exactly. So what you would do here is you would say, for this implementation, you would find out if that participant already had sufficient networks created, and then if not, you would create them. And then you would either keep picking the same network until that network was complete, or you would randomly pick between the networks or have some other strategy for picking between the networks. But this is where you put all of that logic for saying, are people in a network only once? Are they in networks randomly? Are they in a network all to themselves? And this is probably where, if you were creating networks on the fly for people, like Nori was saying, is probably where I would do that. I'd say, check if the user has networks already, if not, create them, and then pick between them.
And the one thing that is, it's actually pretty useful to separate kind of the work of constructing the network, the topology, which is this, what is the role of the other function, this create net, add node to network.
Okay.
That's kind of the topology, and this is the other one.
No, it's not. So this is what defines the topology.
Right.
This is what defines how
the process, and that one is defining the load balance of the who does what.
Yeah. So basically, it's a dependency injection. Like in deep learning frameworks, they also use these nodes and they send the tensors to each other, so it's similar.
Yeah, it's a graph theoretical thing, and we split it into these three things. There is no. You don't have to follow these. This is the best practice. This is how we expect you to write experiments. Nothing's going to stop you from deciding you want to do it all in one function, but I would not recommend it. Effectively, it's this split allows you to do pretty much everything that we've come across. We've never had anyone, as far as I know, say that I could not model my experiment just with these. But yeah. And then there's a few things to implement at the end of an experiment. One of them we've mentioned a few times already is data check. This is where you check if the data is obviously wrong or obviously corrupt. The default implementation of this is just return true, meaning the data is fine. If you return false here, the hit will be rejected, the user will not be paid, they will not get either the base payment or any bonus payment for their participation. The data will be marked as bad data, it will be discarded from all the networks, it will just be forgotten effectively. And a new participant will be recruited to reject this. So this is what you would do for malicious data, as Nori was saying. If someone was deliberately trying to, if you were sure they were a bot, you would make this false. Would you agree?
Yes. One question I have, imagine that we're in a chain. Whether making some data invalid will also trigger failure of the rest of the chain below?
It will not. What will happen is the node in the chain will be marked as failed.
But it's not going to trigger.
It will not trigger anything, but what you can do is in get network for participant, you can use that, see it's got participant nodes failed equals all. You can do a similar kind of check there. So you can say, I don't want to put anyone into this network until I'm sure that the last node hasn't failed.
This is called once each time the person submits the written code.
But
It's not called at the end of the experiment. It's called each time for each agent.
Get data check is
Data check is called for each
participant.
the end of a participant flow.
So when MTurk initiated.
Yeah. So.
Oh, I'm sorry.
So if you have a transmission chain where a user comes in, if you have an experiment where a user comes in, they are given a spot in one or more chains, they finish their stuff, they leave, and then you bring the next person in, then it's really easy because you know that they are always going to be the last person in the chain. So if they fail, then it will just be replaced immediately, right? If you have a situation where there are multiple people acting in the experiment at once, so it's possible that you have already sent the failed person's data to the next person along, then it's kind of up to you to decide what to do.
Yeah, so there's two strategies here. I think what I think, the question whether the default behavior is going to just generating like a down the chain failure. So imagine that you have a chain, and that person in the middle is now, there's other people who added on top of it.
Oh,
If that person fails, I think by default it's not going to fail the rest of them.
No, it will mark it as
But
failed.
you can decide that you want to have this behavior, and then you need to implement it. I'm not sure exactly, but
I think you'll get a fork, won't you? Because like you'll have.
It depends on how you've defined your network. So if you have I don't know the default implementations, chain maybe. I think most of the networks do check for.
I think that the way I
Failures.
implemented in the past when I did want to have this behavior, it's a bit dangerous because it's basically going to discard imagine that you have like a lot of data built on top of it, it's going to just discard it. So at some point I thought that would be the right way to do it, and then I decided not to do it anymore. But in theory, if you want that, I think you just need to override like feature of like fail itself. Like you have to basically make fail all the other nodes that depends on it. And so it's a bit tricky to implement, but if you're really concerned about like data being pure and not really involve bots, then you can do it this way. I would say that there's other ways to filter bots that I think are easier, like filtering tasks and things at the beginning of the experiment. So it's like in the end, it's kind of not necessarily the right way to filter things, but there are certain things that can be only solved by data check. For one of the example, imagine that the participant just close his computer, right? So we're gonna get notification, and as long as you're not gonna put a timely limit on the JavaScript side, or so there's nothing that is gonna happen. So by default, what happens is the time that you spend, like say an hour for the long of the session will pass, and only then that participant is gonna be, this thing is gonna happen. Then would be really cool to fail that participant because it might just like have it's just not gonna.
And that is the default behavior. You can override that if you want, but in the case that a user's time expires, it will not call data check. Data check is when they have said they are complete and you want to check, is it correct?
So
Otherwise,
data check is not called in
no, it will just fail it automatically.
Fail.
Yes, there is a function that you can override if you want to change that behavior, but I know of no reason why you would want to. Maybe you want to check if the user has submitted partial data and.
No, you want to do it if you want to fail all the nodes down the road. Then you probably.
It's one way of doing it. I think generally for this behavior of how a network behaves if it has a failed node, I think I would do that as part of the network.
Mm-hmm.
It's a complex topic. You're only going to run into it if you have a experimental design that has multiple people in the experiment simultaneously. If you have it so that you wait until someone's finished before you bring the next person in, that will never happen. If you have multiple people in simultaneously, you also have to worry about what happens if they're completing things at different speeds. So for that, you are going to have to look at customizing your network logic and deciding, okay, well, if someone is going through it really quickly and there's no space available for them, what do I do? Yeah.
Independently of that, this is indeed a complex hotspot and pretty drastic the outcome. So I was wondering, how would you keep a log of the rationale of a reject, for example, because it could very well be that it is a bug and someone got rejected unjustly. And if there would be a way to notify the user about this specific reason.
So
this is going to another talk, but basically you will never reject the hit. Never reject the hit.
But
Just you never. Okay, you will call this function.
So this is true always.
You will no, but because in here you can do stuff, right? So you can fail nodes in the data check. You can notify yourself that there's no problem. You can do stuff. So that's very useful as a data check, but will not reject the hit. this is just basically a nefas-ast, never do it in Amazon MTurk. I mean,
but then if this is false, what does happen?
Okay, so when you return false from this, the default behavior of Dallinger is to reject the hit. Nori's suggestion is that to maintain a good relationship with Mechanical Turk workers, you should never reject a hit, even if you know it's malicious. So what you would do is you would override the plugin point where it says, no, we don't want to pay this person, and you would say, actually, no, we do. So you would override the way it rejects the hit and say, no, this failed the data check, we're going to mark it all as failed, but we, as a second customization, say, we want to pay people even if they fail. That's not something I have personally done, so I don't have a slide for it, but
So
that is how you
the
approach
other
it.
way around. You can do arbitrarily complex captcha, whatever stuff here, but then at the end of the day, you are returning a bit of information. That is the least amount of information that you could return for a pretty.
But you want to know how you do
process.
more info. And what you would do is every single model in Dallinger has 5 slots for arbitrary information. And we use the first one in quite a few demos, but what you can say is, I want to make slot 5, say, slot 5 on a participant, why I've rejected their data if I have. And then what you would do here is you would say participant.property5 equals and a string response. And then you can show that to the user, or you can send an email, but all that would be custom because by default we don't do that. By default what we do is we do reject people on Mechanical Turk, and there it's slightly more than 1 bit because it's 1 bit for accept or reject, but there's also a status we send. So for data check we send the bad data status. I completely accept that might not be the best way to maintain a good relationship with people on Mechanical Turk, but it's what the software does by default because it's what.
Even for debugging, I would be, if I'm the developer, I would be interested on that specific reject of the specific reason.
Yeah.
But yeah, if I use the API to store that on the database, that also works.
Yeah, but also what you could do is you could just call this function with a participant object from the data export and say, oh, debug it manually. But yeah, for that, I would store notes to myself as a property on the participant.
I think basically the question is the good implementation is probably just to override the functionality later on, but the thing of this function is really useful just right after the experiment to make sure that everything is, prune things that are wrong and make sure that everything that's called right after the participant is doing the experiment. So that's good. Whereas the actual failure in MTurk, which was a property that was envisioned as part of the MTurk environment, was the whole thing that will, like, people have this rejection criteria, and there's a big part of the MTurk system originally they thought of it originally. But the thing is that with practice, this part becomes really not used. And this is not a problem of Dallinger. This is just the way MTurk works. So basically, like a basic criteria for like a lot of the experiments is like recruiting criteria is like over 95 accept rate or over 99, and some participant will have thousands of hits in 100%, and they will fight with you just to keep that 100% accept rate. So I think my take of my message about how to behave in this ecosystem is not to reject the hit unless, like, it's something that I do manually. If I really want to revenge somebody which I'm sure is a bot.
That's the functionality that you're describing matches what he said before about transformations, right? So that would be a cleanup after an output. Or
yeah, but if sometimes there's no reason you have to do it in the end of the participant plot, and that would be a starting point.
I just want to emphasize as well that Dallinger is not written with the assumption that you're going to be using Mechanical Turk. So what you might have is your own recruitment system, and in that case, you might want to reject people because you might want to say, actually, if we're not on Mechanical Turk, we've got a group of people we call in, and we want to keep track of how good they are or not. And then you definitely want to be able to reject people for bad data or for the next one, which is not really paying attention, because that gives you useful information. The practicalities of Mechanical Turk mean that it might be more hassle for you to deal with people complaining than just to pay them the money and cut your losses. That's a Mechanical Turk problem. It's not a Dallinger general recruitment problem. Is that clear? Is that
Yes,
sensible?
but for example, you can use both cases to modify the bonus you pay them, and that will be totally acceptable. So, for example, attention check I use very often to actually stand behind a threat. For example, I tell them, if you just click at random, I have fixed it. I know that because I'm going to have a catch trial or something like that. And then this is the time to actually show your muscles, because they will communicate them among themselves. And if you have a threat and it's an empty, eventually they catch it and communicate it. So it's very good to sometimes implement, like stand behind our threat and actually punish them.
Yeah.
And then that's very useful in attention check. You don't need to actually reject. You just revenge with the bonus.
So attention check is it's like the weaker sibling of the data check. The idea here is you aren't checking if it's bogus data or if it's malicious. You're checking if the user tried. And again, the default implementation for this is to fail somebody if they didn't try. But obviously with Mechanical Turk, that might not be the best idea. What it does do is by default, it will say, if they pass the data check and fail the attention check, they can still get a bonus, which is kind of a bit backwards with Mechanical Turk because people would rather pass the hit and not get a bonus. But this says, okay, well, they did something, but it wasn't really good enough, so we don't want the data to, we don't want to use the data, but we accept that it wasn't malicious. That's what this function is for. And there's a couple of others we touched on briefly. There's assignment abandoned and assignment returned. These are things that are called when the user either exceeds the time limit or they say, I don't want to do this anymore, I want to give it back. And here you can put in hooks to say, I want these things to happen. They call the fail participant method, which goes through and rejects all of the infos and cleans up the space in the networks. In both of these bottom two, you cannot say I'm failing them on Mechanical Turk because in both cases they no longer have the hit, so you do not have that decision. It's just been rejected. But this allows you to put in a callback to say, okay, with assignment abandoned, a timeout has exceeded. You might want to do some special logic if somebody doesn't finish in time. A failed participant is the one that goes through and marks all the nodes as failed. So here is where you might put some, here's another place you might put some special logic for failing a network or failing downstream nodes if needed.
So what happens if the power goes down, or I don't know, the participant pulls the plug? Which one of those methods would get triggered?
It would be assignment abandoned, because that means they have.
It checks every
Um,
second.
It is called when the timeout is exceeded. So Mechanical Turk will arrange for that function to be called when we have not told it that the user passed or failed before the time runs out.
So if the user has Wi-Fi issues, Amazon will decide whether they are kept on the session or thrown away.
And it's based on the time.
That.
It's based on the time that we tell Amazon we want to allocate the user to have. So if we say they have an hour and they have Wi-Fi issues and that hour runs out, then this will get called. If they have Wi-Fi issues and then they get reconnected before that time runs out, they can still keep on.
But before the time runs out, because I know this from, for example, from chess games that you have 1 hour, but you know the other opponent is not going to be 1 hour waiting for you. So the server, after some reasonable amount of time, which actually depends on I don't know what, it gives the opponent the option to claim the win.
Yeah, so that would have to be something you defined in your experiment. What I would probably do for that is something like that, the function where you pick a network for a participant. I would say that, okay, if a long time has expired and you don't want that participant anymore, then you would return none, you'd skip them to the end, whatever. But it would be up to you to implement the logic of allowing someone to say, I don't want to wait anymore. Because in a transmission chain where people are coming in one at a time, it doesn't matter how long they take because nobody's waiting for them.
Yeah.
If someone's waiting, then you have to make these decisions and put them in the relevant places. We mentioned as well bonuses. Bonus, again, it's based on participant, not node, because it's for someone's entire experience with the experiment, not just one particular network. The top one is it returns a number. For Mechanical Turk, that is a number of US dollars. For other recruiters, they can have their own definition of that. So one thing you need to be very aware of is if you change recruiter, you have to potentially change your bonus implementation because it could mean something else. One of the other recruiters that we have built has a configuration variable for what is the currency. So if you start it off with Norwegian kroner and you're saying they get 500 because that's not very much money, and then you decide to run it on Mechanical Turk, you would have a bad day. So bear in mind that is usually, but not always, US dollars. It's recruitment specific. And the bottom one, bonus reason, that is shown to users as to why they got a bonus. The default is just thanks. Thank you for participating. Here is your bonus. But you can there saying, you found the secret button, you get extra money. Or obviously, if you do that, you let people know what they have done to get the bonus. Or you could say, we think you tried really hard here, or we're sorry that took so long, longer than we expected. So say in your ad you said it will take 6 to 10 minutes, and in your bonus you said, okay, the user actually took more than 11 minutes, then you can give them an extra $2 or something and say, sorry, whatever.
You have several overlapping bonuses. So first of all, these are methods of the experiment.
Methods of the experiment,
So you
yes.
just have one of each. So if you have several overlapping bonuses, you implement this in the if structure in the method.
Yeah, so what you might want to do is have them as separate, like bonus under time, bonus under performance, and then in your bonus methods say, get all of them and either find the highest one or add them together, whatever your strategy is for combining them.
Usually, this will allow you to give once the bonus. In MTurk in general, you can just give bonuses right after the other, like giving the participants $100 and again give him another $100 and again $100, and this you can do it in Amazon MTurk. But the way Dallinger works is like you can hack this, but it will usually happen once. And that's like then you aggregate everything and you give them the aggregated one. So you can give them feedback about accumulation of bonuses as the experiment going. With the front end, yeah, exactly. There's a variable called bonus, which is the accumulated bonus so far, so you can use that. But then in the very end, you just like give them the entire bonus, and people love that. Like they don't like to get this. It's very hard for them to keep track of all the bonuses, and so if you start splitting bonuses, they don't like it.
And one thing that is on the to-do list, because it's been requested, I think by Nori and other people, is a command line tool to give people a bonus if you know their worker ID. Because, as you say, if you end up with an experiment that crashes and people send you an email complaining, it's nice to be able to give them a bonus, either through that system we looked at earlier or the Amazon command line tool. This might make it a little easier. It's something that's on the to-do list. Implementation of a bonus might look something like this. This is one that finds the amount of time someone spent on an experiment and then converts that to a number of hours, multiplies it by payment per hour, and rounds it to 2 decimal places. That last line here is very important because if you are calculating the bonus based on anything that the user is in control of, such as their score in a game, if that's sent as part of an info, or the amount of time it takes them, then you are letting them control something that directly influences their payment. So you should always, even if you think there's no way they could get a ridiculously high number, put in something like that. Because what's going to happen if this happens over, for example, daylight savings time, and suddenly it's an hour longer than expected, or this max bonus amount is not a built-in config variable. It's something that you would have to add, but we'll talk about adding config variables later. But yeah, either make it configurable or hard code a maximum so that you know that you're not returning a crazy amount. And also this line is a bit counterintuitive potentially, because you'll notice at the beginning it's min, and what you're actually doing is defining a maximum value, But if you did max there, it would be the highest of either what you've calculated or the maximum you're willing to pay. And what you want to do is the lowest of what you've calculated and the maximum you're willing to pay. So it's a bit confusing, but check these things. If you run it in debug mode or on Sandbox, you will see all these things going through. Just make sure you check those.
I love that your fallback bonus amount is $10,000.
Yeah, well, I'm generous. And performance-based bonus, this is one way instead of using time, you use some sort of check as how well the user has done. This is part of an example in the main documentation for the story-based Bartlett one that we've been talking about a lot today, which is, there's a measure of text similarity. And what this does is it decides the bonus based on how close you were to the text you were given. Multiplies that by the bonus amount, which by default is 0 for some reason. So that you say, okay, bonus amount maybe $10, and then if you got it perfectly, you would get $10. If you got it 50% right, you get $5. If you got none of it right, you would get $0. And again, you want to round it, to limit it to $10,000 or whatever you're willing to pay. Problem with that is there's a really easy way to screw with the Bartlett story demo, which would get you your maximum bonus, which is just to copy and paste it. So what I would do if I was running that for real and I wanted a performance-based bonus, I would use something like this, but also in my attention check, I would check they weren't too good. So I'd say, okay, well, assuming that the text they're working on is more than 30 words, if anyone gets more than 95% accurate, they've probably just copy-pasted it. I don't want that data, it's fake. That's the kind of way I would build a bit of security against people not playing fair and still getting a good bonus.
One question. There is, I assume there has to be some explicit information given to the participants about this criteria. They have somehow to know what criteria are being used to pay them. To what extent do you need to? Because this would be the actor criteria. This definition of this method would be what they need to know.
Yeah.
But I assume you don't want to give them this. So what is the legal line that you want over this?
This is basically not specific to Dallinger. This is a question of when you give performance-based payouts in an experiment, how do you explain the payout structure? And often people use payout structures that are complicated enough that like you're not going to go teach your participants like game theory in order to. But typically, what you do is you give them you usually give them a kind of plain text description. The IRB often has like read the description of what the instructions are for the task, and typically you give them some rule that's like monotonic in their payout. Like, for example, I don't know if you're like you maybe even scale to linearly with it. Like often in an economic game scenario, you might say for every point you earn on the task, we'll give you 2 cents. I guess here the case is like there's some hard to describe criterion that you're checking, and I haven't seen any requirements that say like you need to explain in full detail the checks that you're using to ensure that people are paying attention.
I give you an example. I would assume actually that the pay decreases with the time just to encourage being faster. But probably that's
You
bad.
can do it, but most IRB will not allow it. So what typically happens is the IRB requires a certain amount for time that they spend, and you also can make it depending on the quality.
But
So
independently of that, even if you go up or down, could you formulate it in such a way like time will be a relevant factor in the pay, or do you need to?
I'm gonna show an example. I'm gonna show an example later on how you probably want to do it.
Okay.
Okay. Adding new pages. This is another back-end task. We talked earlier about the fact that there were add, experiment, consent, instruction pages. Sometimes you might want to add a new one to that for whatever reason. You might want to have multiple bits of instructions, or you might want to have a demo of like a video of what's happening, and you want that on a new page. There are two ways of doing it. There's the basic pages, which are just HTML, JavaScript, CSS with no back-end logic attached to them. And those are really easy to create. All you need to do to create a new page is to create a new HTML file in the templates directory. If you name it something that is already used in Dallinger, then it's not going to be there because these things are already there. So if you have add HTML, you're not going to add a new /add, you're going to replace the existing /add. But if you create a foo or a video or whatever, that will be available as just /foo or /video. And you can send users to it with the JavaScript API of the go to page function that we looked at earlier. So here, if I had foo, I would do go to page foo, and the user would see it. But it's pure front-end logic. It's just, this is the way you add it. The more complicated ones are, you can have ones with code associated with it as well. Behind the scenes, Dallinger creates a Flask application. Flask is it's a Python web framework. There's a huge amount of documentation on it. It's really exhaustive, so you can look into that if you want to learn how to do new things. But the quick version is there is something called a blueprint, which is a way of defining a new way of how functions map to URLs. And this will be added in with the default Dallinger ones. So you create an extra roles blueprint in your experiment PY, and then you interact with that as you would a normal Flask app. So it would look something like that. That top line, extra roots equals blueprint, blah, 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 blah. You would just copy and paste that from the docs. You never really need to change that. And then underneath, here is from one of the built-in examples, it's creating a /drawings, and it gets all the infos and then loads the JSON for them and then returns it in a slightly different JSON format. But this is where you would do things like if you wanted a new API endpoint for what's the user's current bonus, where you pass in data and you calculate that and you send something back. You can do this because here you have access to the request object. You can look at the parameters. You can look at all sorts of custom stuff. This is just pure custom Python.
But this, how do, previously there was like a DB call here. So that's...
So info.query.all is a DB call.
All right, so, but just saying that you don't need to get the DB, because if it's inside extra route, you have access to stuff.
Yeah, if you have the model, so you know it's an info, or you know it's an agent, or you know it's a participant, and you do whatever .query, that gives you an object that represents the database query, and then you can either do all to get everything, or .filter, or .join, or there's all sorts of things. It uses an ORM called SQL Alchemy. Again, that's really common for Flask, and there's a load of documentation. You can do some really complex things if you need to. I guess the takeaway from this is not a Dallinger-specific thing. This is a really standard thing, and this is how you get to that level.
But you get access to the Dallinger stuff.
You have full access to all the Dallinger stuff, but you can just write arbitrary Python like a Flask app.
And in the past, there was times that you need to do for those kind of things like update DB. Is there something that still needs to be done? Or not really?
I'm not quite sure what those would be, to be honest. I think generally speaking, the database will just work seamlessly.
So you don't need to do this.
Yeah, you can optionally do things like there's a call which is flush, and what that does is it takes all the stuff that you have created that is eventually going to be in the database and sends it off to the database. So if you create something and then you want to do a query that depends on that, you might have to do flush.
Okay.
But it's relatively rare.
Okay, so that's great.
So this is what we needed for displaying the results of the demo at the beginning, right?
Yeah, probably. But no, this is JSON, so there's probably something in there that would do it. But yeah. Okay, custom configuration variables. I mentioned there was that maximum payout in bonus a few slides ago. This is how you'd make that kind of thing. Dallinger has a bunch of config variables built in. A config variable has a name and it has a type. It has a default value, I believe. Maybe no. No, it doesn't have a default variable.
It does have a default.
Does it?
Yes.
Okay. This is Jesse, by the way. Jesse's one of the developers. He's just got in. It also has a marker as to whether or not it's sensitive. And if something is marked as sensitive, then Dallinger will not show it to end users, which is good because that's where you would put your API keys or your database connection strings and things. So if you want to create a new one, you use the config.
Sorry, can you repeat how exactly would the end user get or device information?
For some reason that I don't really understand, if you just go to the experiment homepage, it tells you all of them. And I've never understood why we do that, but in general, you should think of any that do not have sensitive equals true as being potentially visible to an end user.
But wait, so currently it will also show you secret keys?
No, because they have sensitive equals true. So anything that is marked as sensitive, Dallinger guarantees not to show people. But anything without sensitive, there is no guarantee it won't be shown to people.
And so if I have like API keys like for multiple kind of, if there's S3 and there's a bottle and there's a couple of those things, I can just stack them all in the config and that will be fine.
As long as you say each config variable is sensitive when you first declare it, yes. And the way you declare a config variable is like this. This goes in the experiment PY. And this dance of import get config happens because we're hooking into the configuration system before it's parsed the config files because we need to tell it the things that it's looking for. So this defines 3 config variables: network, which is a string, repeats, which is a number, and n, which is a number. They can be integer, string, bytes, float, or bool for true/false. And register takes these variables. So key is the main name for it. Type, the reason it's got an underscore there is type's a reserved name in Python. That's the only reason for that. So these two just use the first 2. Then synonyms are other ways you can refer to this. And that's mainly useful because you can pass in config variables as environment variables, as we saw with the recruiter equals hot air at the very beginning. So if you know that Heroku passes something in as a specific environment variable, you can give that as a synonym and it will fill it in without you having to put it in the config file. And finally, this sensitive, which defaults to false, you can set it to true and then you're guaranteed that Dallinger won't tell anyone what it was.
But if I, for example, include that information into the transmission, how does
if you
that?
manually add sensitive information to something that is shown to an end user, then it will show it. It doesn't keep track of the data throughout. All it does is it.
So the system doesn't do it by itself.
Yes,
okay.
it will keep it out of logs. It will keep it out of API calls that are built into Dallinger. It won't stop you shooting yourself in the foot. How are we doing for time? Nori?
We're good. We'll still
Okay.
have like good.
I forgot how much there was in this. Okay, so custom infos and agents. If you think way back to just after the break, we were talking about how would you do this structure where you've got some users that have different roles in it. If you have this Turing test where one user creates something and a source creates something and then the next user has to decide which one was real and which one wasn't, you would do that with custom infos and agents. Custom infos are also how you would implement this idea of you want to store data that is not the specific information that is being sent on to the next person, but it's extra information. Info, agent, all these things are classes in Python that you can subclass, and they allow you to put your own implementation of extra methods on, or you can just use the fact that there are two types without any specific code and filter by them. So this one is from the MCP demo. The bit at the top is a bit of magic. This mapper args equals polymorphic identity vector info is just, it's magic. You don't need to worry about it, just accept that it's magic. What's important is this string that you put in mapper args has to be unique for this particular object. So generally what you would do is you would name it the same as the class, but whoever wrote this demo named it something different for whatever reason. So I would do mapper args equals polymorphic identity animal info, because that's the name of the class. And what this is used for is when this is loaded back from the database, it's all stored in one table for infos. So the database layer does not know this was originally an animal info. It could think, oh, is this just a bear info? Is it some other type of info? This is what says, okay, there is a field called polymorphic identity in the database, and if it's vector info, then it's this one. If it is just info, it's the default info. And that's the reason this has to be unique, because if it isn't unique, the database can't tell which class do you want when you extract this from the database.
But this is, I think, similar to how Java serializes objects, and actually another plus of this way of doing things is that you could exploit this to encrypt the objects and solve the problem that we discussed before with this. You could put the cryptographic hash there as a unique ID, and I think that's how Java objects are safely sent across the network.
You could. I don't think I would recommend that without having thought about it properly.
No, sure.
Yeah,
I had read something about the Java serialization. It looks very similar. I cannot certify that it will be safe.
So I also mentioned earlier that we store 5 just generic properties on objects, and you could use one of them to keep a note for yourself. You can use these to set arbitrary data effectively. So this one says, I want something called chosen, and I'm going to store it in property 1, and it's going to be a Boolean. And these 3 together effectively wrap property 1 into becoming a Boolean. It says we're going to call it chosen, and if I'm setting it, then I'm going to say it is the Python representation of chosen, which will either be true or false as strings. So this converts the value here to a string, and then this is converts it back in the database, so it just casts it in the database's implementation. You could also do self.property1 equals true. This, if you're going to do this, you need to look at the SQL Alchemy documentation for how you do what are called hybrid properties, but this is the pattern, this is how it looks. If you see something like this, this means that it's custom data being stored on an info. And the reason we do this, rather than just defining new columns, is because we're using this polymorphic identity to put them all in the one database table. If we had them as separate database tables, then we'd have to handle creating new tables on the fly for every experiment to match all the types of info or agent that you might want to use.
So just to explain how that works in practice, because this is very useful actually when you're creating stuff. So imagine you create a new info. What do you want to have in that info? You want to have all sorts of things. Or imagine you want to store something like generation, which generation is in the network, or you want to store some additional information. So you would like to have in the code like something called info.generation equals something, right?
And this is metadata only. There's content which is separate, which is what the user submitted. We just talk about metadata here.
Yes. So the thing you would like to have in the code is just to think of it as just a random, regular variable. You can set its value, you can read its value, but it's actually in the database, and you actually have a stateless instance, right? So in order to kind of go in bridge, this creates the magic. There's a lot of the nicest properties of Dallingers. You can really program in a very high level, simple thing, info.something, but that goes to the database or set the value in the database. So the only thing that you need to do is just this properties info dot something needs to be set up somewhere. And that's the way you set up this. You set the way that you set it, the way you get it, and the way you make an expression, so equals something else.
And this means you can treat it as a normal property, as you say in Python. You can filter it in the database. You don't have to remember every time, oh, I stored this in property 1, and this is exactly how I stored it. This keeps all your serialization and deserialization in one place.
Yes. So that part is usually you basically, when you create a new info, you decide, okay, well, the property is going to be A, B, C, D is the thing that I've stored. And then you just copy those chunks of code, and you have examples of this is a Boolean, but it could be just an integer or text or anything like that. You just copy those things and change it and order them into property 1, 2, 3, 4, 5. Once you get the database, in the code, you just work with this info dot thing. When you get to see the database, it will be stored in those column 1, column 2, column 3, column 5, and then that's it. It's very, very useful, and it's pretty easy to use. So I definitely, this is something I do for every experiment.
So creating a custom info allows you to add these new metadata columns that work seamlessly. But if you create more than one info, this is what allows you to separate out. These are the notes to myself of what the user has been doing, and then this is their final data that I want to pass on to the next user. So for the drawing, you might have class stroke for a particular line they draw, and then you might have a class drawing, which is, they're both infos. You can get both of them out using the same getInfo methods, but crucially they can be filtered. So you can say, I just want the drawing, or I just want the strokes. And then when you get the data out, you can look at the drawings to see everything, or you can drill down and your analysis functions can say, okay, well, maybe what you actually care about is how long is it before the first stroke is made, or how long are the gaps between the strokes. That's information that you have captured in infos, but you have not passed on as part of the transmission chain. To go along with that, you can have a custom source. This is also really common because you want to have some data in your source, right? You're going to have some initial information that you want to go in. So you subclass source as your custom source. Again, you give it a polymorphic identity, but you have a create information function, and that returns the info that you want your source to create. That can either always be the same thing, or it could be a random one, or all sorts of things. There are two ways of doing it. You can either define create information, where you return the entire info object as you want it, or you can set the _info_type class to be the info, either your custom info or built-in one that you want, and you can then set the _contents method to be the contents. Generally, I would just do create information, but there's this other method if you want it.
No, that part, can you explain again? I didn't get it.
Yeah.
So you can make the source be a copy of an info, right?
A source kind of has an info, effectively. Mm-hmm. So what I would do is, this is how I would do it. I wouldn't bother with the info type and contents, but if you see that, then just be aware that is an alternative way of doing mm-hmm. it. The source is responsible for transmitting an info on the network. Mm-hmm. This create information is the info that it will transmit.
Oh.
Right? So a source isn't like an info, it's like an agent. It sends out an info to somebody else. Okay. So when it transmits, that's actually what this comment is about, is reminding whoever wrote it how it works. This is the info that it will transmit to anyone who receives its info. And this can be this is just Python. You can do whatever you want in here. You can have random stuff, either random contents, or you can have a bunch of canned infos that you pick between randomly. This is what you do. And then this agent, which works in basically the same method. This is a custom agent is what the user is. So you can have custom metadata on there, just the same way you did a custom info. Or what you can do is you can have multiple types of agent. So if I was implementing that question you had earlier, if you were having the sort of Turing test one, I would have two types of agent. I would have a initial information agent and a chooser agent. And the initial information one would be responsible for adding information to creating information, and the chooser is the one who makes the decision. And that way I have a clear distinction in the databases for every person, which role were they playing here. I can store separate metadata on each one depending on what their role was. And this what method here is what defines the information that will be passed on. So if you've created two custom types of info, one of them is notes to yourself and one is data to be passed on to the next user. In this what method, this is where you decide which gets passed on. And you can either return a single info, or you can return a type of info, such as drawing or stroke, and it will return all the ones of that type. Yeah, I think those are the two.
So just to speak, so what is the thing that will eventually, when is what called?
What is called when that agent is told that it needs to transmit its data to the next person in the network. So this is called sort of transparently in Dallinger for you. And by default, what this does is it returns all infos. So defining this is what allows you to say, when it's this node's turn to transmit, and bear in mind, you have told it earlier on to transmit in the add node to network function. We went through and we said the previous node transmits and the next one receives. Sorry. The previous node transmits and the next one receives. When you say transmit, Dallinger goes, okay, what type of object is this? If it's an animal source, then this is a source, and the way source transmits is it transmits whatever create information returns. If it's an agent, or which type of agent is it? If it's an MCMCP agent, then it's this class. So what gets these infos and then does this Python to decide what to transmit. So this what returns either exactly one info to transmit, or it returns a type of info and it transmits all of that type. So if you want to return more than one type of info, all of those have to be of the same type, and it will transmit all of that type. I am aware I've said info a lot. Does that what and the transmit and why you would create these types of objects make sense, or is it still a bit unclear? No one's going to say it's unclear. Why did I phrase it like that? That's stupid of me. Yeah.
It's just a little abstract right now, I suppose. Like, because I get what these things are for and how they would be instantiated and what they do. It's just I don't see how it all comes together yet.
Yeah.
But,
Okay.
We're supposed to have an exercise which was supposed to happen today, but I think it will happen tomorrow. And then I think.
Oh wow! Yeah.
But I think it's good that we took some time to digest that. But I think that the way that it's going to eventually happen is that we will try to go through and guide a demo, and then think through those things again.
Sure.
I'm afraid there's one more of this section, which is transformations. You asked earlier, why wouldn't you just create a class for transformation? This is what you would do. So you would say, this is MCMCP. It has a type of transformation called a perturbation. And then this has a method that takes an info and it gets the contents, it jitters them around a bit, and then dumps new contents. And what you do is in your agent, there's an update method where you get infos, and there's a bit of MCMCP specific things here with replicate, don't worry about that, but the main thing is it creates a new info, and it's an animal info one because that's the type of information you've created, it's the one you want. This could be a different type to the input info. There's no need for those to be the same. It's created by self, which is this agent, origin, and the contents are the result of that method on the transformation. And it creates a transformation from that input info to the new one. So this line is what creates the new info, and then this line is what creates the transformation that links the two of them together. So here we've got a full set of, we've got a type of info. There's only one for this particular one. And we've got a source that generates it. We've got an agent that creates transformations on it and customizes how it will be passed on.
But those are different businesses.
And we've got this transformation, which defines transformation.
If you go back on the slide, I don't understand how so in the new info line,
Yeah.
at the end, this contents field,
Mm-hmm.
it instantiates one perturbation object, but then the next line is a different object.
So
It's
this perturbation.perturbed contents, there's a bug here that should say info in those brackets as well. So this is saying that perturbation class has a method perturbed contents, which given an info will give you the content, what it thinks it should
that
be.
is a static method.
Yes, it's a static method. So this is a static method that returns what the new content should be. And then this says, okay, and I want you to also record that this happened, that it went from info to new info using a perturbation. And the reason this is last is because this defines a relationship between the two infos. It doesn't handle the creating of the info for you.
One last thing. So how would you go about and fetch this? So this perturbed info happens.
Mhm.
Okay, then when the agent, it's a new type of, it's a new type of info, a different class of info.
It can be if you want it to be.
Okay, and
So-
if it's not, it's just picking the last one. If it's gonna be like added to a change, it's gonna be just added to the last one, and that will be the last one.
So what this does is, this particular agent always transmits the perturbed one, and it does that kind of indirectly by saying it's the 0th element of all of the infos available for this agent, and it happens to know that it's sorted in such that this new one it's created is always going to be the first one to come in. So this could be more clearly shown by doing self.transformations 0.info out. Might be a better way of showing that.
Mm-hmm.
But remember earlier we spoke about what would you do if you were doing this story transmission and you were having people record them reading the story out rather than typing it in, and we would have to do a transformation to convert the audio info to the text info. What you would do is you would create two infos. You'd have an audio info and a text info. And then you would have your source would probably be an audio source because you want to prime people with audio. But equally, you could have a text source if you wanted to measure, do people do better if they start with audio or start with text? You would have an agent, which is just an agent for your experiment. You wouldn't have to do anything specific with it, so you don't have more than one type, you just have one type for your experiment. But in the update method, here is where you would do okay, I've been given an info and it's an audio source. I need to go out and get that transcribed and then come back, take the transcription and create a new text info, or whichever way around you're doing it, I can't remember anymore, and then record that. So this is what says, if you have decided to return a different type of info to what you get in, here's how you join those up and you square it so that the next person gets the right thing.
So, and when do you serialize it? Is the perturbation object responsible for that? So, for instance, maybe you don't want to store the whole audio data, but some specific metadata about that. At some point, you would have to call the API to say, okay, put this on the database. Where do you do that?
You do that in the front end with the create info call. So there you're saying, I want to create info with this data. And you either have to give it all the data you want to store, or you have to separately arrange for that data to be stored and then store a reference. So what you might do if you wanted to upload it to S3 is you might create a custom route that says, okay, someone's going to upload some audio and I'm going to store it to S3 and then give a reference to the ID in the bucket and then send that as the data. But that is kind of experiment specific. Generally speaking, your info would contain the actual user specific data. The only reason you wouldn't do that is if it was a massive thing like a big audio recording or a video or a file upload.
And also, actually, you cannot really, if you really store really something like video or audio, you actually needs to first upload it to into Heroku, so to the front, to the backend, and then the backend will manage the content. That's, otherwise you're gonna play around with some security setups, so a lot of browser will block you. So if you actually want to store content that comes from the browser, you can't really do it directly, because it will make this part of the content unsafe. And so usually the way to implement this kind of thing would be to...
I mean, if you have a pointer to this info thing, of course you can do whatever you want to do. I mean, it's Python. You could save it into...
Yeah, just in practice, usually what you do is take this little content of yours, securely upload it into the backend. And then from the backend, you store whatever you need and take care of the, rather than let the front end actually store the content directly. That's first of all less safe, and also blocks a lot of problem of suggests a lot of problems of data security, because people can try to see where they are storing the things and so on. On the other hand, it's going to solve basically practical problems that relates to HTTPS and all of that. So the right way to do it is take the content, bring it to the server, let the server deal with it, and then store reference.
So the important thing is that your info you should always be able to get from an info to the data the user submitted. And whether that means the data is stored directly on the info, or whether it means that when the user initially created that info, you did a bit of behind the scenes hand waving to move the data to a separate storage system that you have faith in, that's all at the create info stage. That all happens when the user submits the data. Here, what we're saying is, given an info, I want to change it to a different type of info, or an info of the same type that is somehow different, and I want to record what I've done, and here is how I move that data forward to the next user. So it's very strictly segregated into different layers. So this doesn't care how you've managed to get the data there, it just assumes that the data is correct.
But somehow it does, right? Because this mapper args dictionary, well, at least as far as I understood, the reason you gave before for it to exist is for us to be able to serialize it and to give it a name so that we can store it on a table or something. But if we are storing it behind some URL, we don't actually need that field.
We do, because we need Dallinger to understand what type of object it is. So if you've got an audio info, we'll go back to info. If you've got an audio info and a text info, and the audio info stores its data in S3 and just stores a reference to it, you still need Dallinger to know whether a specific audio is an audio info or a text info, because when you want to load that info back out of the database, you want to have the right helper methods, and you want to make sure you know what the contents means, because you might store as the contents the S3 bucket path for audio, or just text for the text, and if you can't distinguish between them, then you're telling people to read out the S3 bucket path. Well, that's all the slides for that 1 hour slot.